Hi, everyone, welcome to my channel again. Today, I am going to share about Onesample Ttest. Before watching, please like, comment and subscribe to my channel. Your support will encourage me to produce more videos related to statistic, Lean Six Sigma and operation management. The first step of every statistical analysis is to determine whether the data that you are dealing with is a population or a sample. The population is the totality of items while sample is a subset of the population or portion of the whole and, if properly taken, is representative of the whole. Onesample Ttest is statistical hypothesis test of comparing unknown population means against target mean. Use the test if population variance is unknown. For example, the design engineer claims that this laser tube will require at least 400 microamps of current to produce the desired hole. Another example is the doctor wants to know if the unknown mean cholesterol for patients is more than a goal level of 150 milligrams. Difference between Onesample Z and Onesample Ttest. Onesample Z-test is used when the population standard deviation is known while Onesample Ttest is used when population standard deviation is unknown. Develop null and alternate hypothesis. Null hypothesis or H sub 0 is the statement that we are assuming to be true and we are trying to find evidence against it. Alternate hypothesis is the statement that we would eventually like to support or prove. For a Onesample Ttest, the hypotheses are as follows. In null hypothesis, the population mean equals the hypothesized mean. In alternative hypothesis, there are three options, which are the population mean differs from the hypothesized mean, the population mean is greater than the hypothesized mean or the population mean is less than the hypothesized mean. The test statistic for Onesample T is shown as below. X bar is sample mean, mu sub 0 is hypothesized mean, S is sample standard deviation and N is sample size. For a valid test, we need data values that are. Each observation should be independent from all other observations. Continuous data. The sample data should be selected randomly from population. The population is assumed to be normally distributed. For example, an engineer will like to determine whether the population mean of diameter of metal part is 15 mm at 0.05 significance level. The sample mean and standard deviation is 14.8 and 0.2 based on sample size of 25. The null hypothesis is the population mean equal to 15, while alternative hypothesis is population mean is differ from 15. The level of significance, alpha is 0.05, sample standard deviation is 0.2, sample mean is 14.8 and sample size is 25. Next, I am going to show you the steps of performs a Onesample Ttest to determine whether the unknown population mean differs from 15 using Minitab software. Choose Stat, Basic Statistics, Onesample T. From the drop-down list, select Summarize Data. In sample size, enter 25. In sample mean, enter 14.8. In standard deviation, enter 0.2. Select Perform Hypothesis Test. In hypothesized mean, enter 15. Click Options. Enter 95 under confidence level. Confidence level is 1 minus alpha and multiplier 100. Under alternative hypothesis, select mean not equal to hypothesized mean. The t-value is -5. The calculation method is shown in right-hand side. The p-value is 0.000. The p-value is a probability that measures the evidence against the null hypothesis. The smaller the p-value, the stronger the evidence against the null hypothesis, while a large p-value means little or no evidence against the null hypothesis. The decision to reject a null hypothesis or not depends on the level of significance, alpha. If p-value less than alpha, reject null hypothesis. If p-value greater than alpha, fail to reject null hypothesis. The level of significance used is 0.05. The null hypothesis states that the mean is equals 15. The p-value is less than alpha, reject null hypothesis. We are 95% confident that the population mean is not equal to 15. What if my data isn't nearly normally distributed? If your sample sizes are very small, you might not be able to test for normality. You might need to rely on your understanding of the data. For example, for the energy bar data, the company knows that the underlying distribution of grams of protein is normally distributed. Even for a very small sample, the company would likely go ahead with the t-test and assume normality. When you cannot safely assume normality, you can perform a nonparametric test that doesn't assume normality. Nonparametric analyses do not depend on an assumption that the data values are from a specific distribution. For the one-sample t-test, the one possible nonparametric test is the Wilcoxon signed rank test. Thanks for watching. Remember to subscribe to my channel. Bye. See you next time.